Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be taking a look at fractions. So, what are fractions? Well, if you've come across them before, you'll see this fraction on the board with a number, a line, and a number on the bottom. Now, if I were to ask you to say the fraction that's written on the board, I'm sure a lot of you would be able to say something along the lines of 3/5, and you'd be correct. So let's write that on the board. This fraction is 3/5. But what does that actually mean? Well, in order to answer that question, we need to take a look at what this number on the top of the line and the number on the bottom of the line actually represent. So you may have come across something known as the top number being a numerator and the bottom number being called the denominator. So we have these two words, numerator and denominator, which students use often to refer to the top and the bottom number of a fraction. But these words actually have a meaning. They didn't come out of nowhere. So I'm going to start with what I believe is the more important word of the two, the word denominator. So if you ever think about this word, there is actually a hidden word within the word denominator. And that word is nominate. Now, what does it mean to nominate something or someone? Well, if you think about something like the Oscars award, where the nominations are read out to the audience, what are they actually reading out? So for instance, the nominations for Best Actor, the host would then read the names of the nominees. So to nominate someone is to just name them. So the denominator is the name of the fraction. If we go back to the 3/5, 3/5, the fifths are the name of the fraction. Now let's take a look at the top word, numerator. There's a root word in there as well. Numerator comes from the Latin to enumerate. Now what does it mean to enumerate something? All it means is counting up. How many of the things are there? So count up, or how many of the things are there. So going back to this fraction, 3/5, 3/5. In full, we could refer to it like this. Instead of 3/5, it really means we have 3 of these things called a fifth. So 3/5, or 3 of these things that we call a fifth. Now this definition will be important for later, but for now, let's take a look at a question involving the use of fractions. So on the board we have a typical fraction question, 1/2 plus 1/3. And we have to add these two fractions together. So those of you who studied how to add fractions already will know that we have to rewrite the fractions in another way. So to help explain why we do what we do, let me propose a simpler question, which a lot of you should know how to answer. So on the board I've drawn stick figures, with 3 of them representing boys and 2 of them representing girls. So if I were to then ask what is the total of these 3 boys and these 2 girls, what would the total of them be? Now, many of you will be shouting out or thinking of the answer of 5. But 5 what? Is it 5 boys? I don't think so. Is it 5 girls? No. Is it 5 boy-girl? No, it isn't. You may have said something along the lines of 5 kids. Or some other word to describe both boys and girls. 5 people, 5 students, 5 children, something along those lines. So what's happened here? Well, we can't add these boys and girls together until we describe them both with a different label. We need to give them the same label. So rather than having 3 boys, we can have 3 kids. And 2 girls are also 2 kids. And therefore together, 2 kids and 3 kids are 5 kids. So by changing the label, by changing the name, we can then add them together when they have the same name. This will be important for later on. Now, are there something that boys and girls both have, which there are multiple of? So something that they both have are eyes. And there are more than 1 eyes, typically, on boys and girls, 2 eyes each. Therefore, if we were to add the total number of eyes together, 3 boys have 6 eyes, and 2 girls have 4 eyes. So we could add them together to have 10 eyes. Let's do another example, something that there's more than 2 of. So if we pick fingers or digits, there are 10 on a boy and 10 on a girl. Therefore, with 3 boys, there would be 30. I'll just call them fingers, but the thumb technically isn't. And with the girls, 20 fingers. In which case, the total would be 50 fingers. So, as long as there's a way to label both of these different groups in the same way, we can then total them together. Now, out of these 3 examples, kids, eyes, or fingers, which is the easiest to add together? That would be the kids, because those are the smallest numbers. So, ideally, to make the calculation as easy as possible, we want to try adding things together so that they have the smallest same name. Now, when you add fractions in class, or when you've learned about how to add fractions, you'll have heard of something which is actually the smallest same name. Another word for small is low. Lowest. Another word for same is common. And we've just learned earlier that the denominator is the name. So lowest common denominator. Smallest same name, lowest common denominator. So going back to this question, a half and a third, those are 2 different types of fraction. So we want to rewrite it so that they both have the same name or the same denominator. And this will involve lowest common multiple of the denominators, 2 and 3. So what is the LCM of 2 and 3? That would be 6. So we can rewrite both fractions with a 6 on the bottom. And so how do we do that? Well, 2 multiplied by 3 gives us 6, and we also want to multiply that numerator by 3 as well to give us the 3/6, which is equivalent to 1/2. And 1/3 is equivalent, if we multiply by 2 on the top and the bottom, 2/6. So, if we go back to this 3 of these things called a fifth, that's what we said 3/5 was in full. If we use that same wording for this question, I have 3 of these things called a sixth, and 2 of these things called a sixth, how many sixths do I have? It would be very hard to get the wrong answer from that. We have 5 of these things called a sixth. And when we say it like that, it becomes much clearer why we do what we do in mathematics. So, now that we've explained it, let's try some examples. Okay, so to test if we've understood what to do when adding fractions, let's have a go at this question: 5 over 11 plus 2 over 7, or 5/11 plus 2/7. Well, we need a lowest common denominator, the LCM of 11 and 7, which is 77. So we can rewrite the 5/11 as 35 over 77, and the 2 over 7 is now 22 over 77, which we can then add together to give our final result of 57 over 77. And we'll just make sure we can't cancel this number down. There are no common factors there. So let's move on to another example. Okay, in this example we're doing a subtraction, but the working out is exactly the same as addition. We have 3/4 take away 3/10. So we need a lowest common denominator, the LCM of 4 and 10. Now you might say it's 40, as many of you might like to multiply the numbers together, but remember the LCM is actually smaller because they share a common factor. 4 and 10 actually have 20 rather than 40 as the lowest common multiple. So multiplying by 5, we get 15 over 20, multiplying by 2, 6 over 20. So we have 15/20 minus 6/20. How many 20ths do we have? 9 of them. And this number does not cancel down, so we can move on to the next example. Okay, this next example, we have 4/5 add 7 over 15. Well, the lowest common denominator of 5 and 15 is 15, as 5 goes exactly into 15. So this second fraction can remain over 15, and the first fraction we can multiply by 3 on the numerator and denominator to give us 12/15 plus 7/15, giving 19 over 15. And this answer is a top-heavy fraction where the top number is larger than the bottom number. Therefore, we can change it into a mixed number if we're asked to, in which case we would have 1 and 4 over 15. Now, let's move on to our final example. Okay, in this example, we have 2 top-heavy numbers, or improper fractions. So what we'll do to make things easier, we can change them into their mixed number form, and the resulting fraction will be much easier to add together. So 20 over 3 is the same as 6 and 2/3, and 14 over 5 is the same as 2 and 4/5. So by doing this, we can then separate the whole numbers from the fractions. So we can add the 6 and the 2 together to give an 8, and then we can add the 2/3 with the 4/5. So this fraction, 2/3 and 4/5, have proper fractions, therefore smaller numbers on the top, making the addition much easier compared to the original question. So carrying on, the common denominator is 15. So multiplying by 5, we have 10/15, and multiplying by 3, 12/15. So 10 and 12 result in 22. So we have 8 and 22 over 15. But the 22 over 15 can also be changed into a mixed number, which is 1 and 7 over 15. So we can have 8 plus 1 and 7 over 15, which is the same as 9 and 7 over 15 for our final answer as a mixed number. So, if this video has helped you out, Make sure you give it a like, comment and subscribe. Please recommend to anyone who you think will benefit, and I hope to see you in part 2 where we work out how to multiply and divide fractions. Take care.